All right, so it says Jimmy has a mass of 80 kilograms and Tony has a mass of 100 grams or kilograms. They stand motionless on ice skates facing each other at arm's length on a smooth frozen pond. That means you ignore friction. Which of the following actions will give Tony the greatest speed? And we have to, I forgot, we got to copy the options because basically they give you multiple choice answers. And we did this one before in our homework a couple times. I think the main thing that throws everybody off is who's doing the pushing, right? So what we're looking for, paste those in there. Tony is the one that has to push. Okay? And some people say, well, why does Tony have to push if he's the one that's going to be moving, right? So and that always throws people off. So over here, I have Jimmy. And over here, I have Tony. And so a lot of people want to say, well, if Jimmy pushes Tony, right? They're on ice skates. Okay? That whole Newton's law, every action has an equal and opposite reaction. If Jimmy pushes Tony, Jimmy's going to go backwards because there's nothing holding Jimmy still. You guys are thinking that their feet are firmly planted, so when Jimmy pushes Tony, that'll cause Tony to move. That's not the case. That's not the case. Tony has to push against Jimmy, and when he does, it's going to force him to go backwards because the momentum is conserved. All right? So what does that mean? Well, we said before in the last problem, we said that the impulse, right, because if you notice everything is Newton seconds, so that's an impulse. Well, the impulse is equal to the force times delta t, and it's also the change in momentum, right? Now, if we think about Tony's initial momentum and Jimmy's initial momentum, their initial momentum is equal to 0. So this is going to be their final momentum, which would be m, v, and I'm going to say the mass of Tony and the velocity of Tony will be equal to the force times time. So what they really want is to find v, so I'm going to divide both sides by mt. And so then I get that Tony's final velocity is equal to F delta T over his mass. Now his mass isn't going to change, so I need to find the greatest force times time. And it has to be Tony. So any option with Jimmy doesn't work. So then you got to do the math, right? Which one of these combinations is going to give me the biggest number? So this one's going to be 200 times 0.01. So I'm going to do that on the calculator. 200 times 0.01 is just 2. So this impulse is just 2 the overall is 2 Newton seconds. This one over here is 100 times 0.1. Well, I think that's going to be 10. So this is 100 newtons times 0.1 seconds. Yeah, that's going to be 10. So that equals 10 Newton seconds. And then over here, I've got 200 newtons times 0.08 seconds. So I got to do the math on that one. That's 16. So this is the right answer right here. That'll give us the greatest speed because, and then if you, it doesn't ask you, but if you want to find that speed, you would just say 16 divided by 100 kilograms Newton seconds, which ends up becoming 1.16 meters per second. That wasn't the question, but that will give you the greatest speed. Because the numerator, that impulse on the top has to be the greatest value in order for that to work. Because the bottom will be 100 every time. Okay? Any questions on that one?